In this video, we are going to discuss about properties of continuous time unit impulse function. So the first property is del of t is equal to infinity for t is equal to 0. 0 otherwise, and it has to satisfy integration from minus infinity to infinity. Del of t is equal to 1. The second property is x of t into del of t minus t naught is equal to, so here you have to substitute instead of t, you have to substitute t naught. So this becomes x of t naught del into t minus t naught. Third property is del of t is equal to differentiation of u of t. Then fourth property is integration from 0 to infinity all del t minus tau d tau is equal to, so here you have to substitute instead of tau you have to substitute t, so it becomes u of t. Next, fifth property, x of t is equal to minus infinity to infinity x of tau del t minus tau into d tau. So here you have to substitute instead of tau you have to substitute t, so in order to make this del as 0. Okay, so if I substitute t is equal to tau is equal to t, so here this becomes x of t. So instead of x of tau, I'm going to substitute x of it becomes x of t. So this tau value here it is ranging from minus infinity to infinity, so t also it is within this range. Okay, next, so here you can see this both are same, so instead of tau I'm having t naught, so you have to substitute so this is so instead of so this is different, so here you have to substitute instead of for t you have to substitute t naught, since it is dt. Okay, so if you substitute here instead of t, if I substitute t naught, it becomes x of t naught. Okay, and this term get cancelled out. Next, del of a of t, I can write it as 1 divided by a into del of t. Okay, then here you have one more property. So if I take a as common, I will get t plus or minus b by a. So this a will goes the denominator. So you will have 1 divided by magnitude of a. Okay, since you can see del of minus t is equal to del t. The eighth property is integration of t1 to t2 x of t del t dt, that is equal to, here you have to substitute t is equal to 0, so it becomes x of 0, where this 0 is ranging from within this t1 and t2. Ninth property is integration of t1 to t2 x of t del power n t minus t naught dt. So this n is nothing but the nth derivative, that is you can write it as minus 1 of n into, so here you have to substitute this t becomes t naught, so it becomes d divided by dt of x of this becomes x of n of x power n of t naught. Okay, since I need to substitute t value as t naught to make this one as 0, this n will goes here, so x of n of t naught minus 1 of n to n. So here it is not, so this represents the x of n represent d power n of x of t divided by dt power n, where t is nothing but t naught. Okay, so this is what it represents. Next, del bar of t is equal to d by dt of del t. Okay, so first we'll discuss one problem. So this is asked in 2016 EEE GATE question paper. So the value of minus infinity to infinity of e power minus t del 2t minus 2 dt, where del t is a Dirac delta function. So here you can see del 2t minus 2. So how to write this one? Del 2t minus 2. So according to the seventh property, I can write this one as del. So if I take 2 common, I will get 1 by 2, right? 1 by 2 t minus 1, right? So I can write like this. So now you can see, so this function becomes 1 by 2 of integration of minus infinity to infinity e power minus t del of t minus 1 dt. So here this property is similar to, so if I take x of e power minus t is equal to x of t, so this is similar to the sixth value. So instead of t, I need to substitute t naught. So in order to make this del of 0, in order to get del of 0, I need to substitute t value is equal to t naught. Okay. So similarly, in order to make this one as 0, so I need to substitute t value is equal to 1. So if I substitute t value is equal to 1, so in this one, if I substitute t is equal to 1, I will get 1 divided by e power minus 1. That is nothing but 1 divided by 2e. So that is your answer. So second question, here consider the x of t is equal to 1, where modulus of t is less than or equal to 2. So this represent from minus 2 to 2, it is 1. Okay. Let del t represent the unit impulse function, that is Dirac delta function. So you find the value of this one. So this is also similar to the value of sixth property. So here you need to substitute t values in order to make this one as 0. I need to substitute the t value is equal to 4. Okay. So and you have to see the integration of. So here you can see the t values ranging from 0 to 5. That is t value here now it is 4. So it is within this range. So now I am substituting in this equation. So if I substitute this one, 2 into x of I need to substitute t value is equal to 4, right? So if I substitute 4, I will get 2 into x of 1. So what is x of 1? X of 1 value is 1, right? So this is x of 1, right? So the x of 1 value is 1. So answer is 2. Next. So the next problem, the integral of, so here it is integral. So 1 divided by 2 pi, 1 divided by root of 2 pi minus infinity to infinity t square e power minus t square divided by 2 del of 1 minus 2 t dt. So this is also similar to the value of sixth property, similar to the sixth property. So here I can take del of 1 minus 2 t. So if I take 2 common, I will get so since del of minus t is equal to del t according to the property of ninth property, right? So this is your seventh property, del of minus t is equal to del t. So so if I take 2 common, I will get 1 divided by 2 of del of t minus 1 by 2. So you have to substitute t is equal to 1 by 2, right? So here if we substitute t is equal to 1 by 2, if I take sorry. So in this equation, you can say 1 divided by 2 into root of 2 pi, right? I need to substitute t square e power minus t square divided by 2, where t is equal to 1 by 2, right? So if we substitute t is equal to 1 by 2, so I will get 1 divided by 2 into 1 divided by root of 2 pi. So here 1 by 2 is 1 by 4 into e power minus, you will get 1 by 4 e power minus 1 divided by 8. Okay. So if I solve, I will get 1 divided by 8 root of 2 pi e power minus 1 by 8. So A is your answer. The fourth value, so here the value of integral I is equal to minus 1 to 2 phi of t square plus 1 del t dt. So here you have to substitute in order to make this one as 0, t value is equal to 0, but t value is not ranging from 2 to 1. So this function, we cannot solve this problem, so the answer is 0. Suppose if it is 0 to 2 means I can substitute this value t is equal to 0 and I will get answer as 1. Okay. So next problem, the value of minus infinity to infinity t power 3 plus sine pi t del bar of t power minus 1 into dt is. So this is similar to the 8th value. So since I have 1, I will get minus 1 of minus 1 power 1, right? Here it is x bar of t. So x bar of t, I can write of dx t divided by dt, and instead of t, I have to substitute t naught in order to make this form 1 as 0. So I can write t is equal to t naught. So if I solve this one, right? So here the x of t is nothing but t power 3 plus sine pi t, right? So I can write minus d by dt t3 plus sine pi t, that t value is nothing but here t naught value is nothing but 1 here. So if I differentiate, I will get 3t square plus cos pi t into pi, where t value is equal to 1. So if I substitute t is equal to 1 here, what is cos pi? Cos pi value is equal to minus 1. So I will get here, if I substitute, I will get 3, right? So answer is minus 3 minus, if I take common, 3 plus cos pi into pi. Cos pi value is minus 1. So if I substitute, I will get minus 3 plus pi. So here in order to make the del t value is equal to 0, okay, if I substitute t is equal to 0, I will get answer as 2 here. So here it is nothing but minus 1 power n value is 1 here, then d1 of x of t, that is nothing but t plus 2 divided by dt, where t value is equal to 0, right? So if I differentiate, I will get minus 1, this one is nothing but 1, right? So here I'm not getting any t value, so I will get answer as minus. So here in order to get del of 0, t value should be 0. So what is cos of 0? Cos of 0 is nothing but 1. Next, find the impulse response of the continuous time system, which is given by, the given impulse response is given. Okay, impulse response is nothing but h of t, that is equal to del of t minus 1 in plus del of t minus 3. Find the value of the step response. So if I integrate this value, I will get the step response. So if I integrate this value, so if I integrate this impulse response, I will get the step response. So if I integrate this value, I will get u of t, right? So that is equal to u of t minus 1 plus u of t minus 3. So how to write u of t minus 1? It is delayed by 1. So this is u of t minus 1. and u of t minus 3, I can write it like this. So if I add this one, I will get so up to since this magnitude is 1 and 1, so up to 1 to 3 it is 1. So from 3 it goes to 2, because 1 plus 1 is 2 here, right? So this is a function. They are asking the step response at t is equal to 2. At t is equal to 2, you can see the value of the step response is 1. So answer is 1. Okay. Next, if the step response, unit response of the system u of t is 1 minus e power minus alpha t, what is h of t? So if I want to get the h of t, I need to integrate this one. Sorry, differentiate this one. So if I differentiate this value, okay, if I differentiate this one, I'll get minus of minus infinity into e power minus infinity t. So that is equal to alpha into e power minus t, e power minus alpha t. Okay. So here, in order to make this one as 0, I need to substitute t value is equal to 1. So if I substitute here, you will get e power minus 2. Okay. So what is the definition for del of t? So this is from the first property. So you have two properties, right? So so this 2 will not come. Okay, from this one I can this is the answer. So you can refer the first first property. Del of t is equal to infinity, t is equal to 0, 0 otherwise, and it is ranging from minus infinity to infinity. Del of t dt is equal to 1. So this is your property, right? So D is your answer. Next, see here the integral of minus into infinity del of t minus pi by 6. Here you have to substitute t value. So t value is equal to pi by 6. Only if I substitute that one, del becomes 0. So you will get 6 sine pi by 6. So what is 6 pi by 6? 6 pi by 6 is 1 by 2. So you will get answer as 3. Okay. Next, if y of t is y of t plus integration of 0 to infinity y of tau x of t minus tau d tau is equal to del t plus x of t, then y t value. So if we substitute the answer b, that is y of t is equal to del t here. So if I substitute here, you will get del t plus integration of 0 to infinity del of tau x of t minus tau d tau. So in order to make tau value is equal to 0, if I substitute in order to make this tau value is equal to 0, I need to substitute tau is equal to 0. So del tau is equal to 0, tau value is equal to 0. So if I substitute here, I will get only x of t. So this is my answer. Right. Next, which is not a property of impulse function. So here you can see I need to substitute x of here in order to make this one as 0, right? So you have to substitute t is equal to t naught. So it becomes x of t naught into del of t minus t naught. So if the function is in convolution, you have to entirely replace this t by t minus t naught. Okay. Next, here in order to make this one as 0, you have to substitute t is equal to t naught. So you will get x of t naught. Okay. So the convolution, you can see I am having convolution on the integration. Will not have the del function, that is unit impulse function. But if I do the multiplication, I will have the del function, that is t. You have to replace t by t naught, and you have an additional term. Okay. So if you see the final equation, that is this one d. So here minus 1 of minus 1 power n is missing. Okay. So the fourth equation is wrong. That is not the property. So I hope this video is useful for you. Thank you.